Hello everyone. I am Mayank Pradul, software development engineer from PSET at Autodesk. I joined Autodesk around 3 years back, and from the very start, I have been involved in the data exchange project. And mostly, I was involved in the GraphQL APIs that we built. Today, I, with my team, would be presenting before you Autodesk Data Models brought to life with three connectors and GraphQL. Let's get started. So, this presentation will be a case study of how GraphQL was used to build data connectors between Autodesk platform and third-party application. Our team collaborated with System Integrators to produce three connectors for Microsoft Power BI, Power Automate, and Autodesk Dynamo. Each connector shared common and unique integration challenges. We would like to share our journey of discovery that resulted in customer utility and how we brought Autodesk data models to life through successful integration use cases. Let's start with a fundamental truth. Data is powerful, but with great data comes great responsibility. As Autodesk moves towards platform thinking, we recognize the need for a unified and efficient way to access and manage this data. In this session, we will explore how GraphQL, along with data connectors, helps us streamline access to Autodesk's rich and complex data sources. We will take you through real-world case studies where we overcame integration challenges, delivering impactful solutions for our customers. By the end of this session, you will see how these technologies can enhance workflows, improve efficiency, and open new possibilities for your application. Now let's talk about Autodesk Data Platform and our adoption of GraphQL. Autodesk is moving towards a platform-centric approach, and data access is at the core of this transformation. With so many products and tools across AEC and manufacturing, each producing valuable data, we need a better way to connect everything. In the past, developers mostly use REST APIs to access this data, but REST can be a bit rigid. Sometimes you get too much data, that is overfetching, sometimes not enough, that is underfetching, and it can lead to performance issues and sometimes frustration. This is where GraphQL helps. It allows developers to ask for exactly what they need, nothing more or less. This makes apps faster and improves the overall developer experience. So as you can see this diagram, here you can see the shift. On the left, we have the Autodesk ecosystem. The middle shows GraphQL acting as the bridge. On the right, you see different industries and solutions built on this unified data platform. With GraphQL and Autodesk platform services, developer can now easily integrate with our data models and build better and more connected experiences. Let's take a closer look at how Autodesk organizes its data and make it available through its APIs. So Autodesk has industry-specific data models to handle the unique needs of different types of work. As you can see in the diagram that I have here, the AEC data model is built for architecture, engineering, and construction. The MFG data model, that is on the most right side, is focused on manufacturing and product design. In the center, we have something called as data exchange. It enables interoperability, making it easier to integrate Autodesk data into third-party applications. This acts like a translator. It helps different tools and system data with each other, even if there is a different language. All of this is powered by GraphQL APIs. And this would be our center of focus for this whole presentation as well. These API let developer ask for exactly the data they need and only that, making this faster and simpler. These models and APIs help make sense of complex data, connect different Autodesk tools, as well as link Autodesk with third-party apps like Power BI or Dynamo. This means smoother workflows and more possibilities for automation and integration. Our customer use many different tools depending on their needs. For example, Power BI is great for dashboard and data analysis. Power Automate helps with automatic repetitive tasks. Dynamo is used for visual programming and computational design. But here there is a challenge. Getting Autodesk rich data into these tools wasn't always easy. That's why we stepped in. We worked on building 3 dedicated connectors, one for each of these tools. These connectors act like bridges, making it easier for customer to plug Autodesk data directly into their workflows without jumping through hoops and writing complex code. This means more time solving real problems and less time fighting with the data access. All 3 connectors are powered by Autodesk's GraphQL APIs. The Data Exchange GraphQL API and AEC Data Model GraphQL API is the common thread. It is integrated into all these 3 connectors. The MFG GraphQL API is integrated into the Power BI connector, specifically enabling insight from manufacturing and product design data. This layered setup makes these connectors versatile and powerful, allowing them to serve a wide range of workflows while still relying on a unified GraphQL-based architecture. Now that we have set the stage, let's dive into the heart of our presentation, a real-world case study on how we built these data connectors, the challenges we faced, and the lessons we learned along the way. Each of these connectors serves a different purpose, but they all share the same goal, making Autodesk data more accessible and usable, no matter what tool you are using. Let's start with a quick overview of these 3 connectors that we have built. Let's begin with the Power BI connector. Let's begin with the Power BI connector, one of the most impactful integration we developed. These connectors allow Autodesk data to be directly integrated into Microsoft Power BI, which is widely used for data visualization, reporting, and business analytics. It connects to Autodesk Data GraphQL APIs as well as the AEC and MFG Data Model GraphQL APIs, depending on the customer's industry. With this setup, user can pull in the project data, design metadata, asset information, and more straight into Power BI dashboards. Once the data is inside of Power BI, user can slice, filter, and analyze it however they need. They can create custom dashboards, visualize trends over time, monitor project performance, and even combine Autodesk data with other business systems. What is powerful here is that non-developers like project managers or executives can now work with Autodesk data in a familiar tool without needing to write a single line of code. These connectors make Autodesk data more visible, more interactive, and more valuable across the organization. It's a huge step towards unlocking data silos and making design and project data work harder for the business. Next, let's take a look about the Power Automate connector. This connector brings the power of automation to Autodesk data by integrating with Microsoft Power Automate platform. While Power BI helps you understand your data, Power Automate helps you act on it automatically. The connectors tap into Autodesk Data Exchange GraphQL API and AECDM GraphQL API, allowing you to build workflows that respond to changes in your design data without writing any code. For example, you can set up automated notifications in Slack or Microsoft Teams whenever a specific data is updated, like a new version of model being shared. You can also trigger flows to update costing spreadsheets automatically based on Revit categories, parameters, or other metadata from your models. This connector is all about reducing manual work, keeping teams in the loop with real-time updates, so that Data change don't get missed and tasks don't fall through the cracks. It's a powerful tool for connecting Autodesk data to rest of your business ecosystem, bringing automation, speed, and accuracy to everyday workflows. Now let's look at the Dynamo GraphQL nodes. Our connector built specifically for design automation and visual programming in the AEC space. This connector is a part of the AEC data and data exchange APIs for Dynamo integration. It's a game changer for data interop within AEC workflows. Traditionally, Dynamo was used mostly for scripting within Revit, but with this connector, we have gone the way beyond. It connects Dynamo directly to Autodesk data, giving user the ability to query and interact with project data in a much more flexible way without needing to be a full stack developer. Now user can pull in the data from any design or exchange, use that data to drive custom logic or project automation, and then visualize that in form of GraphQL nodes or pass data along to other tools. This means Dynamo scripts are no longer isolated into a single model or file. They can now become part of a larger connected workflows across the platform. It opens the door for more advanced use cases and creating reusable logic blocks that work across multiple tools and disciplines. This connector is all about empowering computational designers and BIM managers to do more with the data without having to leave the tool they are comfortable in. Before we jump into the broader integration challenges we faced with our official connectors, I want to take a moment to get a bit more hands-on. Let's talk about how I built a Power BI connector using our GraphQL APIs from scratch. This will be really useful for developers who want to build their own connector or need something very specific for their own workflows. It's a great way to get Autodesk data into Power BI your way, especially when you're working with unique reporting needs or very specific use cases. This also helps answer a very simple question. What's the first step a developer can take to build a connector? Once you understand the basics, you will see how easy it is to get started, and it opens the door for building many more custom connectors in the future. Here is how I did it. This was a proof of concept, but it shows that anyone, especially developers, can connect Autodesk GraphQL APIs to Power BI using built-in features. No extra tools needed. We start by settling up the essentials. The GraphQL endpoint where the request goes, the headers, which include authentication so we can secure access Autodesk data. We then define a simple GraphQL query, in this case, just to pull the hub's name, ID, and reason. Since GraphQL queries are as are sent as a post request, we wrap the query in a JSON payload. Power BI's web.content sends the request. When the JSON response comes back, we parse it with JSON document and converts it into a Power BI table with the table.fromList function. This process isn't just useful for Power BI. It's a helpful pattern for building any custom integration, even beyond Autodesk's platform. The key takeaway is, once you understand this flow, you can build new connectors from almost any tool. Let me show you the exact code that I used to build the connector. This is written in Power Query M language, which is what Power BI uses behind the scenes. We start by setting the GraphQL endpoint URL. This is where the request is sent. As you can see in the screenshot, I have used Data Exchange GraphQL API here. Next, I define the headers. Content type is set to application JSON because we are sending a JSON payload. And we include the authorization header with a bearer token, which gives us access to the Autodesk APIs. This is just asking for a list of hubs, and for each hub, we want its name, ID, and reason. But Power BI can't send this query directly. It has to be wrapped in JSON and converted into binary text. So that's why post body line does, it prepares the payload for the post request. After that, I use web.contents function to send the actual request to the API. I also included manual status handling to catch any errors like 400 or 500. Once I get the response, it comes back as raw JSON. So I use json.document function to parse it, then dig into the nested structure to get the actual list of hubs result. Finally, I convert the list of records into proper Power BI table using table.formList function, and that's our final output. What's great about this approach is that it's entirely code driven, flexible, and works with any GraphQL query you need. And once you have this template, it's easy to tweak the query or use it as a base for more complex connectors. What you are seeing is a Power BI table showing a list of all the hubs I have access to, along with their names, IDs, and reasons. In this example, you can see hubs from US and EMEA region. This confirms that the GraphQL query worked as expected and the data is coming in cleanly. It's also a great validation of the approach. We have successfully used Power BI to connect to Autodesk APIs, fetch real-time data, turning it into something usable for reporting. Once you are at this point, you can do anything Power BI supports. Filter, join with other data, build dashboards, or even schedule refreshes. Now that we have pulled the data into Power BI, this is where it gets really exciting. Here is a dashboard I created using the hub data. And as you can see, it includes a pie chart, a data table, letting us visualize everything instantly. This was all done in just a few clicks once the connector was set up. No extra coding, no complex setup. The pie chart helps us quickly understand how our hubs are distributed across regions, like US versus EMEA. And the table gives us a clear and sortable view of the raw data, names, IDs, and reasons, so we can drill down further if needed. This is kind of the foundation that makes custom connectors powerful. It's flexible, visual, and driven by exact data you need. Now, I will hand it over to my colleague Bryce to talk more about the integration challenges we faced while building the connectors. Thank you.
Hello everyone, I'm Bryce. I'm a principal engineer here at Autodesk. For the last few years, my focus has been on the Autodesk Data Model GraphQL APIs, specifically working on MFG and AAC GraphQL. Now I'll go over some common challenges we faced when developing connectors and what we learned by overcoming these challenges to hopefully make your lives easier if you ever decide to create a connector yourself. So first, we'll talk about issues of authentication authorization. Then we'll go over how you can optimize the GraphQL queries you make. We'll talk about the data transformation process. We'll talk about some limitations of each connector technology. Then we'll go over how to handle rate limiting and throttling, best practices of testing complex flows, and the learning curve of getting this all working. Okay, so first, the first challenge people encounter when creating a connector using Autodesk GraphQL APIs is usually with authentication authorization. To send a request to an Autodesk GraphQL API, you need to generate a free hello token with your APS client ID and the user context. Handling this OAuth flow on tools that don't natively support it, like most of these connectors, requires a bit of work. We recommend to get started to pass in a token as input to your connector, and then develop the full oath integration only later when needed. If you encounter any issues with a full oath integration, please reach out to us. We've done it before, we can help. The next difficulty people encounter is with token management. Autodesk bearer tokens expire after 1 hour, so if you want to have a connector that has a long-running job that is very complicated or dealing with a large data set, you're going to need to add code that handles token refreshing. Yeah. Another common mistake we see is with GraphQL query design and optimization. Unlike REST with GraphQL, users have a lot of flexibility with the queries they make. This is both a blessing and a curse. A blessing because you can make queries which get exactly the data you need in a user-friendly fashion. A curse because you can make queries that return way too much data and thus are slow. So we recommend here is to be aware that the more data you ask to be returned, the higher latency the query will have. So you should make sure that all of your GraphQL queries are not overfetching data and are only getting the data you actually are using. Something to note is all data returned by the GraphQL APIs are paginated. So when dealing with larger data sets, you'll have to make the connectors handle this pagination. The good news is all our GraphQL APIs use a common cursor-based strategy with an identical structure. So once you handle pagination once, you can reuse that all over the place. Another thing is in GraphQL, you can make very large complicated queries. Be aware that this can make pagination difficult. If you have multiple levels of pagination in a single query, it's not easy to get the next page. So sometimes it may be better to split a large query into multiple smaller queries to simplify the process. Next, now let's talk about some common difficulties you may encounter with parsing the data from our data models. Firstly, GraphQL returns structured, nested JSON, but tools like Power BI or Power Automate often expect flat or normalized tables. You could directly dump the JSON into these frameworks, but it won't be very useful. So the brunt of the code you'll have to write when creating a custom connector is to convert the GraphQL responses into a format that is useful for the connector framework. Another challenge with parsing data is parts of our data models are dynamic. For example, both AEC and MFG GraphQL have custom properties that are from user-defined schemas. So make sure your parsing code is flexible and fault tolerant. It should ignore unexpected data instead of throwing errors, etc. Another thing to consider is units. A lot of data within the system has a corresponding unit, and the unit might not be the same units you're used to seeing in the UIs of your applications. So when making GraphQL queries for parameters or properties, make sure to also ask for the unit in request, and then handle unit conversion if needed. We are planning on adding more options surrounding units and units conversion and APIs to make this process easier in the future. Next, we're going to talk about some customer-specific limitations, some connector-specific limitations. For Power BI, there are no native GraphQL connectors, so we had to build a custom data connector using M language. It wasn't that easy to properly set up the token refreshing process. For Power Automate, there is limited support for more complex HTTP requests, which made it challenging to run GraphQL queries and transform results into usable actions. So just be aware that sometimes things might not be as intuitive as you expect when writing this connector. For Dynamo, you need to ensure real-time interaction with the Autodesk Data Model, which can be difficult when handling very large data sets. Next, there are some challenges dealing with rate limiting and throttling. All Autodesk APIs have rate limits associated with them. If you make too many requests in a minute, you'll get 429 errors as responses. Note that for GraphQL APIs, we also have rate limiting based on not just the number of requests, but also on the complexity of requests being made. Something that you might not expect is connectors pull or refresh data decently often, which might accidentally trigger your rate limits. So be aware that your API usage might be higher than you originally expect. So make sure you know the rate limit of APIs you are using, and if you know you'll need a higher rate limit, contact support and we can work with you to increase the rate limit of your application. To provide a more stable experience with your connectors dealing with these rate limits, we suggest adding retry logic whenever you receive a 429 error. Your retry logic should use exponential backoff to avoid constantly re-triggering the 429 errors and actually just making things worse. Another challenge we encountered is with debugging complex workflows. When debugging a connector, there's sometimes a lack of visibility of what is going on. Debugging a multi-tool, multi-step flow with large responses isn't easy, especially in tools like Power Automate. What helped us a lot is having some unit tests which completely mocked out our downstream data. So this made it easier and quicker to figure out exactly where the problem is occurring. We also suggest creating some test environments with sample data that mirror your production data for safe testing, especially when you're looking at workflows that will write back into our systems. So overall, there is a learning curve at creating these connectors. Once you get a basic flow working, adding additional flows is pretty easy, but getting that first flow working can take some time. Hopefully, this presentation will help simplify this process for you. To write connectors, you have to become familiar with GraphQL, Autodesk Data Models, and the connector frameworks themselves. We found that for a connector to be useful, we have to do multiple rounds of iterative refinement. Sometimes the connector was made too specific, so it wasn't very useful. Other times, too flexible, so it was hard to use. User feedback was vital in making the connector be what they are today. So now I'm going to pass it off to Sashi to talk about real-world use case that demonstrate the power of these connectors.
I'm Sashi, Principal Engineer in Autodesk PSET Product Data. Over the 3 years, I'm working with MFG Data GraphQL APIs. And today here, I'm going to talk about Power BI connector in action, and also will share some real customer success stories around using these Power BI connectors. So let's walk through with the real world use cases to demonstrate the power of these connectors. Now we will see how this Autodesk data can be pulled into Power BI for visualization and reporting, and how GraphQL simplifies the data retrieval and makes analytics more efficient. So let's start with this a real customer requirement. So a customer come with a requirement. He want a cost estimates for painting the wall of his office building, but he don't want to share the office entire layout with any contractor. So for this requirement, this is possible. Yes, with Power BI connector, it is possible. Here, user can load the model in Revit, and he can connect Power BI to model using Power BI connector, and fetch only the required properties such as wall area without exposing the entire layout. And also he can create a dashboard with only few drag and drop option that you'll see in next slide how that dashboard will look like, and with very minimal clicks he will be able to create those dashboard, and will find it out the wall area and find out the cost for painting the wall. So here you can see you can select any visual of your choice from visualization pan. Here you can see a pie chart, and from the data pan you can select any Revit category such as wall, floor, ceiling, anything, and he can create using these data, these dashboard, and we'll find out the sum of area for the walls. So in this slide, you can see the sum of area is this, and with very minimal drag and drop option, you are done. And also here in the viewer, that model is visible. You can check the Revit category with few clicks only. Okay. So that was for AEC. And here the similar thing you can do with MFG data also. So the similar dashboard, if you want with MFG data model, that also possible. So here you can see MFG assembly, MFG data model assembly is there, and you can visualize that assembly and the component, and it allow you to track material and component at granular level. Okay. One of the most valuable report for any manufacturer is the bill of material or BOM. Power BI connector makes it easy to generate BOM report by integrating the MFG data. You can see exactly which components are used, track cost, and even identify opportunities for cost saving by optimizing material usage. So this is one of the example of bill of material that you can get from the Power BI connector and use for further analytics. Now move on to the impact of connector and how customers are using these connector, and the stories we have from the real customer. Let's move on to that. Okay, this is the example from CRB. They are using Power BI to compare model quantities and estimated quantities on their construction project. Here we can play a video. Note that here the gray bar represents the estimated and budgeted quantities, and blue bars are remaining quantities. This gives them an overall percent complete and visibility into progress by system. They also merging two data sources. Here elements come through data exchange and data coming from ACC asset module. CRB can see, here CRB can see asset properties like ID, category, family, etc. Here you can see. This allow user to drill down to individual asset, see its status, and view how much it contribute to the percent complete of overall project. And also he can see the status. Okay, so the next example we have from customer Turner Fletcher. shared their first experience using Data Exchange Power BI connector. This first dashboard that was created just a simple space allocation diagram where he sliced his Revit model by just one floor and included just furniture category and walls so that he can start to do a department assessment. How many desks are in this floor were associated with which department. Pretty straightforward, but incredibly easy to do and visualize in Power BI. So he had a pretty good experience and was happy to share his feedback. This is whole setup from Revit into Power BI. It's just amazing. The ability to control how much data is in the pocket, really exciting result. These were the feedback from our customer using these Power BI connectors in action. Okay. One more example we have for the customer Roger, how they have used this Power BI connector. So they have very special requirement here. They were monitoring steel installation. First, they break the steel into sequences and then plot those sequences out over a schedule. And that's what you can see in upper left. Then given the reported progress on the installation, they can estimate and even try to predict when the steel installation will finish so that other trades can start their work. And this all boils down to communicating insight with their subcontractor. So we work with them in getting this code. We sum up and value of using data exchanges. Our team wants to see updates every day since we know what steel is installed and what's remaining. Our dashboard is the communication tool to push subcontractor. Because if steel is late, it's going to be impossible for the rest of the project to stay on schedule. So these are the our customer real use cases, how they have used these connector and how they are fulfilling their use cases using these Power BI connectors which we have developed. Okay, so these are the few examples we share and few key takeaways will I would like to highlight. With these Power BI connector, you can extract only the data you need securely and efficiently and visualize it in a minute. It's fast, flexible, and user-friendly. And to summarize, this GraphQL is the future for data access within Autodesk ecosystem. Our data connectors have already demonstrated their value by simplifying integration and improving workflows. Looking ahead, we are expanding GraphQL adoption across Autodesk Pharma, Fusion, and Flow, all across the industries. We encourage you to explore our APIs and start building innovative application with Autodesk platform. So, yeah, that's we have for this presentation. Thank you so much for attending this. If you have a question, we are here.